All right, so for this one, we've got 4-1. That says that an op amp with an open loop voltage gain of 10 to the 6 and the VCC of 12 volts has an inverting input voltage of 20 mu volts and a non-inverting input voltage of 10 mu volts. What is its output voltage? So let's draw that up first. So it says we have an op amp. That's the first thing I draw. And then I'm just going to put these on. So we have our ins and our outs. That's the first bit for this problem. Then the thing it's going to say, we're going to do our V out. And this is going to be, it says 12 volts, which means this one is minus 12 volts. Okay. And now it's going to ask for, on the negative side, an inverting input of 20 times 10 to the minus 6. And on the positive side, 10 times 10 to the minus 6. And this is open. So we're going to get our equation for V out equals gain times the difference between V in. So V voltage positive minus voltage negative. V out equals gain times V positive minus V negative. So we're going to plug this in. V out equals 10 to the 6, which is given in the problem, times 10 minus 20 times 10 to the minus 6. All right, so that's a 10. That's 10 to the minus 6. Minus 6 is going to cancel. And that's going to equal minus 10 volts. These two cancel out. Okay, and then this is this minus this. So 10 minus 20 equals minus 10. Okay, so we're going to also look then at our saturation. Minus 10 is going to be less than 12, and therefore good and unsaturated, which means that this is going to fall within the linear region. So again, just to kind of draw this out, this is not part of the problem, but so let's just say this is 0 volts, this is, I don't know, we're powering this with 12, so let's just say this is 12, and then that means this one is minus 12. Let's just say I have a signal that comes in. Let's do this signal. This is our input signal. It's coming in like this. Okay, what the op amp is going to see for this signal, well, it's going to cut it off at this point across because it can't go higher than 12 because it's the power we're giving it, and it can't go lower than minus 12. So the op amp is going to see this flat, flat, flat. Okay, so this is what the op amp is going to see. So that's why we have to check if it's saturated, because if it's saturated, these regions are saturated. That means they're going to be just data that's missing in our final thing because we haven't properly sized our op amp. So anyway, that's why this is important, to see saturation or not.